I am honored to introduce you Tony Drake, who is going to talk about air disaster investigations, what they teach us about computer forensics, and kind of how to tie it all together.
All right, everybody. Well, thank you for joining us. As she said, my name is Tony Drake, and this is what air disasters teach us about computer forensics.
Tony, you muted yourself accidentally. Sorry to interrupt you.
No, that's fine. Just getting the hang of this. So, first, a quick disclaimer: air disasters, in many cases, are immeasurable human tragedies. This talk is not attempting to draw parallels between the impact and human tragedies that we know are air disasters. Rather, we are trying to look at investigative techniques and how they have developed techniques that we can use in our investigations. So, first, a quick NTSB history. After all, if you're going to look at somebody, why would you do that if you didn't know who they were? So, the NTSB history starts in 1926 with the Air Commerce Act. That gave the Commerce Department the ability and authority to investigate air disasters. This later became the Bureau of Air Commerce in 1933, followed by the Civil Aeronautics Administration in 1938, the Civil Aeronautics Board in 1940, and in 1967, the NTSB was created as an independent agency, and in 1974, they were given additional authority for investigations. Now, the reason these years are important is not because there's a test at the end, but it's because in 1974, give or take, depending on who you read, that is the year of the first computer network. So they worked on air disaster investigations for 48 years before we had a network. 1987, again, give or take, is the year that the events chronicled in the Cuckoo's Egg were kind of wrapped up, and that book was published in 1989. The reason I mentioned the Cuckoo's Egg is that was kind of the first big public expose, if you will, of computer intrusion activity. So the charter of the NTSB is very simply to be an independent federal accident investigation agency, and its mission is to determine the probable cause of transportation accidents and formulate safety recommendations to improve the transportation safety in the United States. Now, if you move these words around and you change them a little bit with computer words, you have the charter of a forensics and incident response practice in most large corporations. So why are we looking at them? Well, I kind of alluded to this before, but essentially they've been doing this a long time relative to how long we have had computer networks to investigate. And they have developed kind of procedures and things that they do that work very well that we can adapt in order to do better investigations and get better results. So, what is it exactly that they do? The first thing is they get there fast and preserve the evidence. This is key for them. If you've ever seen the pictures in the news or in the newspaper, you know, that thing that was always wet in the rain that used to be at your doorstep before we had all this TV news and internet stuff. You'll see the crime scene tape and the guards posted and the people kind of milling around. This is so that they preserve the evidence until they have identified and documented and kind of chronicled the scene as it exists. They also, at this point, start looking for black boxes. The next step is to get the records. They have to lock everything down and preserve everything they can. So the air traffic control tapes, the the radar tapes, the meteorological data, the ground crew data, the manifest of the cargo and the plane. They want to know everything there is to know about this plane and this crew and this flight before the plane ended up as an air disaster. The next step is to interview the witnesses. And these are non adversarial interviews. These interviews are tell me in your own words everything you saw, everything you know, what happened in your words. And they just listen and ask questions And they do these very quickly before the recollections can change, before they can be tainted by other accounts, because small data in witness testimony sometimes can be very important later. The next step is to process the evidence. Once you've got all these boxes and all these things, you have to tag them, you have to identify them, you have to gather the data off of the black boxes. You have to get everything in order so that you can refer to it during the investigation as you go. Next, they identify all the possible causes. We know that we started with a flight and we know we ended in a state, and we want to know all of the reasons that this particular start ended in this particular state. So they go through all of the possible causes: human, mechanical, psychological, social, meteorological, and they draw up a list so that they say, okay, here are the possible reasons. Here are all of our hypotheses about what could have happened. The next step is to run all of the hypotheses to ground. You look at every single thing that you have on the board, and it becomes either a yes, a no, or a maybe. And that leaves you with your probable causes. That leaves you with the most promising leads that you can investigate. And remember that the first failure is not necessarily the only failure. Most failures are cascade failures. There wasn't one thing that occurred. The next step is to test this out. And a lot of times they take the black box data and what they've learned and they go to the simulator. The idea is to look for the evidence of each failure in the simulator and see how people reacted versus how they should have reacted. And if the way that they reacted contributed directly to the plane ending in the state in which it ended. Next, you create the end-to-end narrative. So you have a timeline and you have all these things that occurred. Now you tell the story and you show how all of these events led to the outcome that you are now investigating. Last, you make recommendations. In the case of an air disaster, the recommendations become binding actions via the FAA and other regulatory bodies. This may mean changes to the airframe, changes to manuals, changes to training, changes to the cockpit. It just depends on what the incident was and what is required to remediate. Pardon me. So that's great, but how does this apply to computer forensics? That's great because we're not investigating air disasters, we're investigating computer incidents. So what does this have to do with us? Well, I would argue that there are 5 areas that we need to look into in order to be more like the NTSB and to have better results. They are gathering data, digging deeper into that data, simulating and confirming our hypotheses, accounting for human factors, and solving for all failures. Gathering data, in my view, is unfortunately the worst area for computer forensics. I have a good friend, he tells me that the obstacles to effective computer forensics include we don't have that data, it's too expensive to get, keep, or maintain that data, or it takes too long to get that data. In my view, there is no such thing as too much data. I don't think, and the others who do more of this than I do can probably confirm, I don't know any of us who has ever said, man, that investigation was so easy. I had so much data. I had every packet. I had every log. I went through, I finished up, and I started my Maui vacation 3 days early. I bet they would probably say more of their investigations end like this. Man, that was brutal. They had nothing. I had to do everything from scratch. I think I have a pretty good idea what we came up with, but man, this would have been easier with logs. The next area is digging deeper into that data. Now, we are all busy. We are all way too busy. There are more tickets, more cases, more incidents than there is time, money, resources, and people to deal with. There is a tendency to try to move on quickly after you get the first win. Okay, we know what happened, let's move on. However, if you find and document all of the contributing factors in detail, though it takes more time, you get better results and you are better able to help your organization prevent a repeat of this incident. Simulation and confirmation. Now, this is something that I have only seen done very rarely, and it is so powerful. This web server had an intrusion. We think that they used this particular exploit. Make a copy of the web server, granted much easier if it's a virtual machine than physical. Make a copy of it, put it in a lab, and run your tools and duplicate what you saw in the investigation logs. And if you can duplicate it, great. You now know that this particular tool, this particular exploit is what they used because your logs match the investigation logs. On the other hand, maybe they're similar. Okay, so maybe they used a different version, or they're not the same at all. Maybe there's another CVE, maybe there's a 0-day, maybe there's something else you need to find. Then once you found it, then you patch it and you try again, and you can show that this patch prevents this vulnerability from being exploited in this way. You have positive confirmation now that doing what you are recommending will fix the problem that led you to do this investigation. Accounting for human factors. We live, work, and breathe in a digital world when we're doing forensics. However, at the end of all that stream of bits and bytes and packets, there is a human. A user clicked a link, a user opened an attachment. Those are not the human factors. A more accurate human factor is Mary was running late for a meeting on Monday and had a business trip at noon. When she arrived at the office, she saw an email that said airline ticket confirmation, which she clicked on, which turned out not to be her airline ticket, but turned out to be malware. A user interacting with someone else, with someone who they think is someone else, this is your classic BEC. Why do users do this? I would argue it's fear. The emails are written with phrases like, don't tell anybody, I need you to help me with this. And so what happens is the user doesn't check. Where what I would argue is that we need to instill a culture of checking, a culture of verification, where the user, when they see that email, calls up the admin assistant for the CEO and says, is Joe Smith in the office today? Yes. Well, I see here that he sent me an email at 7 a.m. Can you confirm that? He didn't send me an email. How do you know? Oh, his laptop is in his briefcase next to your desk and he's been in a board meeting all day, which he didn't dare send an email from? Maybe this was not from the CEO. Processes not getting completed or checklists not being finished and training. These issues, again, tend to have more complex reasons behind them. The server did not get patched on time because there was another incident and the team did not have time to get to this server. The checklist did not get completed because the user who was doing it was new and they did not realize that there was this extra step that you had to do that wasn't in the checklist, but we're working on updating it, and therefore the step got skipped and the configuration was incorrect. These are the types of things that we need to understand that we get by actually interviewing the users in a non-confrontational, non-adversarial way to understand why they did what they did. Then investigating and remediating all failures. Almost all failures, as I have said before, are cascade failures. There's no one cause. There is a first cause. There are multiple causes along the way, and there are multiple contributing factors along the way. We need to make sure that we address all of these factors and all of these causes. This includes adding to security awareness training. Maybe we need to take screenshots of the email that purported to be from the CEO and put it in our security awareness training social engineering module so people see actual samples instead of what we put in our training. Maybe we are missing detective or preventative controls along the way, and we need to work to better instrument certain paths into our environment. Or maybe we need help in the SOC. Every one of us who's ever worked in a SOC will know this story. This alert triggers 99 times a week. This week it triggered 100, and that 100th trigger happened to be malicious, whereas the other 99 were benign. What do we need to do? We need to tune that alert, or we need to educate the SOC on what makes alert number 100 malicious while 1 through 99 are not. Writing it up. So we have now, if we follow this kind of process, we have now spent a lot of time writing about what we saw, what we did, what happened step by step. And now we have to document it. And this documentation should be very comprehensive and should also be very, very flat. It doesn't need to be placing blame. Mary should not have clicked on the link. It should be, more basic of a user clicked on a link because she was expecting an email, and it turned out that this malicious email happened to be similar to the one she was expecting. When we clearly document what happened in that level of detail, it paints a much different picture, and it gives us a much better idea on how to respond to these problems in the environment and prevent future recurrences. Then we make recommendations for each. We need to improve our social engineering training. We need to look at our email providers and determine why these emails are getting through in spite of having 6 hops between the internet and the end user. We need to understand why certain end users are clicking on certain types of emails more than others. We need to look at these kinds of things, and we need to make these recommendations, because when we understand our users and understand our environment and understand our business at that level, then we can make recommendations that will truly help to prevent future incidents. The next step is probably the hardest. You thought all of that digging and documenting and writing reports was hard. This is hard. We want our report to do more than sit in a digital file cabinet. We want our report to have an impact on the organization by reducing future incidents. In order to do that, our recommendations have to actually get implemented. A recommendation that sits in a report does not help the organization. So I would argue that forensics reports should be treated just like audit reports or pen test reports, in that each finding and each recommendation should be tracked, it should be assessed, it should be risk ranked, and the appropriate people should decide what to do about it so that it doesn't get ignored. So putting this all together, how do we take what the NTSB does and apply it to make better forensic investigations? It's these 3 things. We investigate and document all causes and all contributing factors instead of the first. We dig deep into each of those factors to fully understand the incident, the users, the environment, and how they all contributed to cause the incident. And we simulate the attack in the lab to verify that we truly understand how the incident occurred, and we verify that the fixes we are recommending actually solve the issue that caused the incident in the first place. So that's it for me. Now it's your time to talk. So let's go to Q&A.
Excellent. Okay. I see one here about computer black box. Can it work?
No, computer black box is an interesting idea. A lot of people don't know, but one of the original web traffic recording devices was actually called Network Flight Recorder. And it tracked all of the network traffic going out to the web. This was probably circa 2000. There are network black boxes. There are computer black boxes. If you look at the various types of artifacts on a system. The problem is that most of those black boxes, most of those logs, most of that registry data, et cetera, is not kept or is not kept for long enough to be useful in an investigation. I can't count the number of times that I have been doing something and discovered that the data I need rolled off the sim a month ago.
Okay, here's another good question. How do you address the idea that we need to stop the bleeding? So essentially finding issues as soon as possible without a ton of time to investigate.
The word for that is triage. There are always two levels to every incident response. There is the triage level, which is where are we, what happened, and what's going on. And then there's the deeper level. And what I'm talking about here in a lot of ways is that deeper level. You still have to do the triage. You still have to, find out what's going on right this minute and stop the bleeding, as you say. But you can't stop the investigation. There is the point.
Excellent, thank you. Here's another one for you. Do you have any recommendations on effective report writing?
There are some courses on that. I don't remember them off the top of my head. I will have to look them up and put them in Slack. But there are people who teach courses in InfoSec report writing. I believe Chris, can't think of his last name, is one of them. But a lot of it has to do with just basic business writing and the basics of writing that we all hated in English class about, get to the point. I believe when I was in English class, they told us, tell them what you're going to tell them, and tell them what you told them. Kind of format writing is probably the simplest report format I could ever give you, and it works very well to this day.
And you know what? So Tim, did you see Tim's comment in there right now about human factors? I feel like human factors impact almost every aspect of DFIR. If you think about it, that's usually the biggest point of failure.
Well, as I said, I mean, we're looking at bits and bytes, but behind those bits and bytes are humans. In the keynote, Chad was talking about how much time and effort SANS spends in order to make realistic environments for investigation classes. And the reason that is so difficult is because human factors. Humans exchange email at a rate that is different than the automated bots we create to create evidence for classes. That's why we need to use humans to create for classes. And the same thing happens in a lot of areas. And that's in forensics, that can be a tell. No human could have done this. This had to be a bot. So it goes both ways.